Hey all, welcome back. So in today's session we are going to talk about how we are going to write the constraint within the function. Okay, so in yesterday's video we have already discussed about how we are using the constraint within the inheritance of the class. Like when you are using the inherited class, how you are going to write the constraint within that inherited child class. So in today's video we are going to discuss about how we are going to use this constraint when we are writing the functions. So if you see the example here, right? So this is my class which is having two properties which are value and select. Okay, and this select is of bit, so it will be having only two values since it is scalar. So if you see here constraint value, see, okay, what is my limitation here, what is my constraint here, value equal to, I didn't give any, if you see here, get values of select. So this get values of select is nothing but this is the function. Okay, so I'm just writing the constraint, I'm just writing the function within my constraint. Okay, so here within this function what I'm doing, I'm writing the bit select. Okay, I'm just going to return this value. So this select is the return value for this particular constraint. So for this return value, what is the condition I'm writing? Select question mark. So that is conditional operator. So if select is 1, then 10 is going to be the output. If select is 0, that means if this is true, this is being executed, and if this is false, the second statement is being executed. You already know about conditional operator execution. So this is the return value of my select and then end function. Now within the module, I'm just randomizing this particular item. Okay, item is nothing but the sequence item handle, so I'm just randomizing these two values. Okay, so while randomizing the values, okay, I'll be displaying what are the values that are being randomized. So here within the constraint, what will be the value? Value will be equal to get values of select. That means based on the select bit, the output value will be either 10 or 20. Okay, so here if select is 1, that means if select is true, then the output will be 10. And if select is 0, because you are randomizing it for 3 times and the select is single bit, so it can be either 0 or 1. Within these two, it can be either of these. So when you are randomizing it for 3 times, if it is 0 for 3 times, then the output will be obviously 20 for the 3 times. And if it is 1 for 1 time, then the output will be 10. Now if you see the output here the constraint value is 10. That means here the select is 1 for the first time and the select is 0 for the second time, select is again 1 for the first time. Okay, in this way I have randomized the values and I am just displaying the constraint value. So the constraint value is either 10 or 20. Okay, so and then so after randomizing it for 3 times, I'm just giving the value, I'm just referring the value. Like if you see here, item dot get values, I'm just giving it as 1. So the select is obviously 1 here. I'm not randomizing, but I'm passing the value here. Select value, I'm passing the value as 1. So the output will be obviously 10. Okay. So this is how you will be writing the function within the constraint. Okay, so in function when you want to write a constraint, you will be writing it this way. By just calling the return value of that particular function, you will be putting that limitation within your constraint. Okay, so this is how you will be writing the constraint. This is the example, like how we are going to write the constraint when we are writing the functions. Okay, hope you all clear about this, right? And then how to disable the constraint, like we have seen many of the constraints until now. Okay, like we have seen distant inline constraint and inside constraint. Similarly, how we are going to write if else within constraint, how we are going to write conditional operators. So all these things we have seen. There are still lot more constraints, but whatever the constraint is, if we are having the opportunity to disable that constraint, that means what is constraint actually, you all know that it is just a limitation. Okay, when it comes to limitation, you can put the limitation and you can also take off that particular limitation. So how are you going to do that? That is done by disabling that particular constraint. So how are you going to disable that particular constraint? We have already seen how we can disable the randomization within the particular thing. Okay, the same concerns for constraint also. Okay, so in randomization we have already discussed how we are going to make that randomization to rand mode 0 and rand mode 1. Okay, similarly if you want to disable the constraint, when you by default when you are writing the constraint, that means the constraint mode will be 1. Okay, but when you want to disable it, then what you have to do, you have to make it as constraint mode 0. Okay, based on the constraint mode function, you will be blocking the constraint, or you will be enabling or disabling that particular constraint. Okay, we'll see it as an example so that you can easily understand. Now if you see the example here, this is my address. Okay, so now I'm writing the constraint. So what should be my address value? It should be either 5, 10, or 15. Okay, so this is my limitation. So this is 3 down to 0. That means it will be having some 2 power 4. Okay, within 16 values I will be only I only want these three values to be randomized. Okay, so I'm just giving it as address inside. Now everything you all know about everything about this, so display. Now if you see here, before constraint disable, that means I'm using the disable function here, constraint disabling function here. So I just want to check the values before constraint is being disabled. Okay, so here value of constraint mode, I'm just knowing whether the constraint, okay, in order to know whether the constraint is in enable or disable position, you will be using this particular thing. Okay, constraint mode, right? And then you have randomized, and then you are disabling the address. Okay, and then after displaying this particular address, then you are going to disable the constraint. How we are going to disable the constraint? You will be by it you will be giving that particular order. Like if you see within this packet, okay, this packet is having the handle packet dot. Okay, and within the packet what you want to actually like disable, you want to disable this particular constraint. So what is the name of that particular constraint? You have to give this packet dot. Okay, constraint name dot. So you want to make that as constraint mode 0. So you want to give that function which is constraint mode 0. Okay, so this is how basically you will do. Okay, so after this you will be just displaying something like now you want to see the constraint mode. After disabling, you want to see what will be in this mode, and then you will be displaying packet.address. Now if you see here, okay, before constraint, that means before disabling the constraint, okay, you want to display the address. So before disabling the constraint is present here. What is it? So the value can be either 5, 10, or 15. Okay, and the constraint mode is 1. Since the constraint is activated, so constraint mode will be 1, and then the address will be either of these three. Okay, either 5, 10, or 15, right? And then after this, what you have done, you have disabled that particular constraint by using this particular function. So after disabling, what will be the mode? The mode will be obviously 0 because you have disabled that. Now since you have disabled that, the value can be anything between 0 to 16. It can be 5, 10, and 15, but it can be anything between 0 to 16 because you have completely disabled this particular constraint by giving this particular, by calling this particular function. Okay, since you have called this function, so this particular condition is being disabled, and so that is why what is the original randomization without any limitations as being into taken into consideration. Got my point? So this is how you will be using the disable randomization. The same thing you will be seeing for randomization also. Okay, but for constraint you will be making the constraint mode as 0, whereas for randomization you will be using rand mode. Okay, the rand mode, based on the rand mode is either 1 or 0, the randomization is either activated or deactivated. Okay, so this is about the disabling of constraint. Okay, and then the next important thing is static constraints. Okay, so this static constraints is also very important within this among the constraints that we are learning. Okay, and one easy technique about this static constraint is we have already learned many concepts regarding this static keyword. Is it or not? I have explained during the classes also. We have explained about like what is the static keyword, like what are the static classes. Okay, we have already seen about what are static classes and all. Okay, I'll leave the system verilog playlist where I have explained every concept in detail. You can check that playlist where I have explained this static keyword classes, about static classes also in detail. Okay, but for your reference, like in order to have a just reference, okay, you don't need to check everything. I'll just give you a small reference. Basically, okay, when you are writing the class, okay, so if you are for example, if you see the before examples also, you will be taking packet. If you see here, this is my class. Okay, for this I am taking handles, like packet is pket is my handle. Similarly, for example, when your class is having three handles, that means you are creating three items for your original class. Okay, now what happens? If you see here, these are my three handles for my particular parent class. Okay, so for these three handles, you will when you will be using new. Okay, new keyword. So when you are using the new, that means the object is being created. So whenever you are creating object for these three handles, so the three memory locations will be created for these three different objects. Okay, so now what happens? Now within this object, since you have used the new, you have created the object, so the memory is being created, and so you can value store different values among these three handles. Okay, so this is what basically happen when you think about classes. Now for this same thing, if you are doing with static class, what happens means the static class is nothing but whatever handles that you are using. By using the static class, the same memory is shared among all these handles. Here if you see, since this is not static class, so that is why each class will be having its own object and its own memory location. But when you are going in for static class, what happens means all the handles, like if you are taking the three, not only three, if you are taking some 5 or 10 handles also for your class, everything will be sharing same memory location. Okay, here they will be having their individual memory location, but here all handles will be sharing the same memory location. That means all instances, or these are nothing but class instances, so all these instances will be sharing the same memory location. Okay, so that is the difference between normal class and static class. The same goes for normal constraint and the static constraint. Okay, static constraint also, like that means the normal, when you are going for normal constraints, then when you are taking two handles for example, when you are taking two instances, and when you are writing for two constraints for these two instances, that means they will be stored in different memory locations. But when it comes to static constraint, so that means all these handles will be sharing the same memory location. So which is why any changes that is made in with the help of one handle will bring the changes in the remaining handles also. Okay, I will just explain this with the example so that you can easily understand it. Don't worry about it. Okay, let me give you a small example with on a EDA playground. Yes. So this is the code. If you see here, okay. So this is my class. I am taking the class in which I am taking two properties which are value 1 and value 2. Okay. So for this both value 1 and value 2, I am writing two constraints. Okay, so my first constraint is I'm naming it as value 1c constraint. Okay, and value 1c constraint, what is the thing that I'm writing? Value 1 is inside 10 down to 30. That means the value 1 value will be between 10 and 30. Just remember this. Okay, and for the value 2, what is the constraint I'm writing? The value 2 should be either 40, 70 or 80. So these are the three things that the value 2 should have. So these are the two constraints I am writing, in which the value 1c is normal constraint and value 2c is static constraint. Okay, now these are the two constraints that I'm using within my particular code. Now if you see here, for this particular class I am taking two handles which are item 1 and item 2. And if you see here, for both these handles I am sharing two different memory locations. Okay, I have created two objects, so that means two different memory locations are being created for item 1 and item 2. Okay, now I am randomizing them, like with both handles I am randomizing the properties. Now what happens when I am randomizing? Item 1 dot randomize, value 1 and value 2 only will be randomized, and for item 2 also again value 1 and value 2 only will be randomized, but four different values you are getting basically here. Okay, that means value 1 value 2 for item 1, value 1 and value 2 for item 2. Okay, got it, right? So before disabling anything, whatever I am doing, okay, before disabling I just want to print what are the values that are actually present. So what I am doing here, dollar display. So what are the values? I told you four total values. What are it? With item 1 value 1 and value 2. Okay, similarly with item 2 value 1 and value 2. So the four values. Okay, differently, like based on item 1 and item 2 I am taking two different display functions. And then after this, what I am doing here is with item 2 handle. Okay, you just remember, you just listen this carefully. With item 2 handle I am making my constraint mode as 0. Okay, so this item 2, with this item 2 handle I am making the constraint mode as 0, and then again the same process, like again I have made this item 1 dot randomize, item 2 dot randomize, and then the display, everything is same, but the only thing that I have done in my second step is that with item 2 I am disabling the constraint value 2c. Okay, I am disabling only value 2c. That means I am only disabling the second constraint. I am not disabling the first constraint. Okay, you should remember that, because if you see here, item 2 dot with item 2 handle value 2c. Okay, so this is what I am disabling. That means this is what that shouldn't happen after disabling the constraint. Okay, so the first constraint should be in that actual mode only. Clear? So this is what that is happening. Now if you see it, if you run this particular code, what happens? Let us see how the output is going to be. So let us see before thing, like before disabling, how is it going to be? So what are the constraints that I have kept? So value 1 should be between 10 and 30. So value 1 for item 1. Okay, it is 12. So it is between 10 and 30. Okay, this and then about the second thing, it should be 40, 70 or 80. So value 2 is 70. Fine. Okay, this is for item 1, and then again with item 2 I am again randomizing it. So it should be between 10 and 30, so obviously 30, and it should be between 40, 70, 80. So 40, 70, 80. Fine. Okay, so this is what that had happened before disabling the particular constraint. Now what is the constraint that I have disabled here? I have disabled with item 2 handle. Okay, I have disabled the value 2c constraint. So the value 1c shouldn't change actually. So let us see. So if you see here, item 1, with item 1, okay, value 1 is obviously between 10 and 30, so it is 18. Okay, and then again for, if you see the value 2 here, it is changed. Why? Because Here if you see, you have changed, you have made the constraint mode to 0. But with what handle have you done? You have done with item 2 handle. So if you are doing with item 2 handle, only item 2 should be disabled. That means only you can expect the value 2 as 129 here. But here if you see, the value 2 for item 1 is also changed. Okay, if you see here, I have only disabled with item 2 handle, but also even though I have changed it with item 2 handle, the item 1 handle also being changed. Why? Because I am using the static constraint, which is why both item 1 and item 2 are sharing the same memory location. So which is why any change that is made with second handle is being impacted in the first handle. Now what we do is, let us just delete this. Okay, let us make this both as just normal constraints. Okay, without any static keyword. If you see this particular constraint, now you can see the difference. Now if you see here, since both are normal constraints, I have and I with the item 2 handle I have just made the constraint mode as 0, which is why now if you see the output with item 1 handle, the value 2 is obviously 40, 70, 80, because I have disabled for only my item 2 handle, and that is not static constraint. That means they have their individual memory locations, which is why only item 2 value 2 is only changing its value. Okay, got my thing? So that will be the difference between static constraint and the normal constraint. Okay, this static constraint and normal constraint, even though it appears to be very easy, but while we are executing or while we are estimating the output, if you don't know how actually is this process is going to happen, then you will be getting confused, which is why I have explained this with an example for you. If you still didn't understand, you can pick me in the comment box. I'll definitely explain this to you one more time if you are not understanding about the static properties or static constraints. But static is very important within not only in constraints, because in classes, okay, and within classes also, within static methods, okay, static functions, so everywhere you will use the static keyword. Any point, like at any point you use, either it is classes or methods or functions, in whatever uh, particular concept you are using the static keyword, the only thing that you should remember is, when you are using the static keyword at any point of time, that means there will be some amount, something like sharing. Okay, that means they will be having, or any, if you are using any number of instances also, all these instances will be sharing the same memory location when you are using the static keyword. Okay, so this is about the static keyword, static constraints within the particular memory location, sorry, within the system verilog. And then the next thing is unique constraints. Okay, just like static means sharing the same memory location. From the name itself, unique constraint means basically you will be mostly using this unique constraint within when you are using, when you are writing the constraint for arrays. Basically, when you will be using the writing the arrays, and when you want to put the limitation on that particular array, then you will be using this constraints mainly. Okay, mostly for fixed, any kind of array you are writing, you can be using this unique constraint. So that unique, from the name itself you could say, because if you see here, this my array of 6, that means it is having 6 elements. So when you want all this, when you are randomizing this particular array, so when you want these 6 elements to be unique in nature, that means different elements, because randomization means there may be repetition. So in order to avoid that, you will be using this unique constraint here. Okay, now If you see here, for this unique constraint, what is the syntax going to be? So you will be just writing the unique keyword. Okay, so unique variable 1, variable 2, variable 3, and unique array. Okay, now you are writing the function for displaying all the variables and arrays, and then you'll just be writing the module. Here if you see, you are writing the program or module, both are same. We'll be discussing it further, like in the upcoming classes. So within this, here I'm just writing the randomization and display. Okay, if you see here, just like 3 down to 0, so it can be anything between 2 down 2 power 4, which is 16 elements. So among this, you'll be having individual, like unique means everything will be unique in nature. That means every value that you are, when you are using the unique keyword, that means you can expect any, if, every time you randomize, you can expect a new value. Okay, you don't expect any repetitions when you are using the unique keyword, right? That is the only thing. So this is about the unique constraint, and in the next class we are going to see about solve before constraints. So after this you will be seeing soft constraints and all, so don't miss that session also. And if you like my video, please do give it a like, and also share this to all those VLSI aspirants who are also want to enter into design and verification domain and are doing courses on Verilog system, Verilog, etc. Right? Thank you all.